In this question, we want to determine the values of A and B such that the following three planes, either A intersect along a line, B do not intersect, or C intersect at just one point. Well, we can see right away that the normal vector of the first plane is 3, 2, 5. Normal vector of the second plane is 6, 1, 8. The normal vector of the third plane is B, 3, 6, but we can tell that it's not a scalar multiple of any of the others, even though we don't know the value of B, because we know that the 3 and 6, there's no way that this ratio could remain consistent with either of these two normals. In other words, it's impossible for this to be a scalar multiple of any of these other normals, even though we don't know the value of B. So what we're going to do in order to answer this question is to set up a matrix. 3, 2, 5, 10, 6, 1, 8, A, and B, 3, 6, 2. Now normally you'll see me try to develop zeros in these two entries by getting each of these entries to equal whatever that first number is. However, in this case, I realize that that's not going to be possible since one of them is a variable. So what I'm going to do is modify my approach a little bit and try to develop all the same entries in the middle column. So I see that if I multiply this first row by 3, the second row by 6, and the third row by 2, I get 6's here. Then I can subtract row 1 minus row 2 and row 1 minus row 3, and then revert row 1 back to its original form. And when I do that, I get this as my next two answers, as my next two, the two rows in my next matrix. Well, now I see that, again, I can't eliminate anything here, but by multiplying this row by 11, I can set it up to eliminate in the next step. So I multiply the third row by 11, and when I add row 2 plus row 3, I get this as my next matrix. Now, I know that in order for these three planes to intersect along a line, that this entry and this entry have to both be a 0. So that means that 72 minus 22b has to equal 0, which means b is 36 over 11, and 316 minus 6a has to equal 0, which means a would have to equal 158 over 3. So that's what has to happen in order for them to intersect along a line. Fair enough? What if there's no intersection whatsoever? Well, if there's no intersection whatsoever, then we know that we've got 0, 0, 0, and a non-zero value. Well, we've already determined that getting a 0 value here would mean that the b value is 36 over 11. So if we have a b value of 36 over 11 and an a value that's anything other than 158 over 3, then we've got no intersection whatsoever. Now how about if they intersect at a point? Well, that's really simple. For them to intersect at a point, it just means that we've got a non-zero entry here. This can be 0, but as long as we have a non-zero entry here, and we can have a non-zero coefficient in front of the x so that we can solve for it, we'll be happy with that result in order to have intersection at a point. So we set that up by simply saying b can't equal 36 over 11, and therefore this is not a 0, and we have an intersection at a point.